There's this idea of building the plane while you're flying it. Well, what OpenAI did with ChatGPT was kind of like building a rocket ship while it was heading to the moon. Today, we're going to pull back the curtain and see exactly how they scaled their database for what became one of the fastest growing apps ever. And trust me, the answer is probably not what you're thinking.
Okay, so picture this. You build something amazing. It takes off, and suddenly you have nearly 1 billion people knocking on your digital door. How in the world do you keep the lights on? How do you stop the whole thing from just collapsing? That was the massive question OpenAI had to figure out, and they had to do it fast.
And here is the absolute craziest part. They pulled it off with a database that looks like something you or I would spin up for a weekend project. Seriously, it looks more like it belongs in a tiny startup than a global tech phenom. No wild, futuristic, custom-built tech. Just a good old-fashioned, off-the-shelf database. And that's where this whole story gets really, really interesting. All right, so let's pop the hood on this thing. What does this startup at scale architecture actually look like? Well, you're about to see the simple, almost surprisingly basic foundation that somehow managed to hold up the weight of the entire world's curiosity. Here it is, the heart of the whole operation. It was just one single primary Postgres database on Azure. This was the writer, the one in charge of handling every new message, every new conversation. And then, to handle the absolute flood of people just looking at stuff, they had an army of about 50 read replicas spread out all over the world. It's a super common setup, right? One boss, a bunch of helpers. Simple, but as we'll see, incredibly powerful. So the big question is, how on earth does a simple setup like that not crumble under the weight of hundreds of millions of people? Well, the secret isn't really about the technology. It's about us. It's about how we, as humans, actually use a tool like ChatGPT. Just think about how you use it for a second. Most of the time, you're just looking, right? You're opening the website, you're scrolling through your past chats, you're reading an old conversation. All of that is just reading data. The only time you're actually writing anything new to the database is when you hit enter on a new message. So for the vast majority of your time, you're basically just window shopping. And that's the genius of their approach. Since most of the work was just reading, they could scale by just adding more and more of those read replicas. It's kind of like having a library with only one author who writes new books, but 100 librarians who can help everyone find and read the existing ones. It's a brilliantly simple solution for a ridiculously massive problem. But, no system is bulletproof. And as ChatGPT just kept getting bigger and bigger, those simple foundations started to show some serious cracks. The little engine that could was about to hit a very, very big wall. This is the part of the story where the database starts to fight back. So what was the bad guy in this story? Well, it's a weird little feature in Postgres called MVCC. Now, the easiest way to think about it is this. Imagine you're writing a document, but you're not allowed to use the delete key, ever. Instead of fixing a typo, you just cross out the whole sentence and write a new, correct version right below it. It's great for keeping a perfect history of changes, but you can imagine how messy that document gets over time. And that messy document creates some huge real-world problems. They call the first one write amplification, where one tiny little change forces the database to create a whole new copy of the data. Then you have read amplification, because now, to find the right version, the database has to sift through all those old, crossed-out versions. All those dead rows lead to table bloat, which is just wasted space making everything slow. And finally, you have the cleanup process, auto-vacuuming. That's like the janitor who has to come in and erase all the old stuff, but sometimes, to do his job, he has to lock the entire library down. Not good. And that is exactly how a death spiral begins. First, a sudden spike in traffic hits the database. Then everything starts to slow way down as the database struggles to keep up. That's rising latency. Pretty soon, users start seeing error messages because requests are timing out. And then the final blow, the retry storm. All the automated systems start hammering the database again and again, desperately trying to get through, which completely floods the already drowning system. And game over. Okay, but OpenAI's engineers are brilliant. They didn't panic. And they didn't just rip everything out and start over. Instead, they got methodical. They created a playbook with a few really smart strategic moves to get things under control. Let's walk through it. Play number one was just being honest about what Postgres is good at and what it's not. They realized it wasn't the right tool for everything. So for the really intense, write-heavy jobs, they moved that work over to a different system entirely, Azure Cosmos DB,
which is built for exactly that kind of thing. Right tool for the right job. Next up, they went on a hunt for the most expensive, slowest queries that were bogging everything down. And they found a real monster, a query that was joining 12 different tables together. Yikes. And what they did next is something a lot of developers would find weird. They actually took that complex logic out of the database and moved it into the application code instead.
So why on earth would you do that? Well, the logic is actually genius. Think about it. Your main database is this one single bottleneck. It's really hard to scale. But your application servers, you can have thousands of them. You can scale them out like crazy. So by moving that hard work to the application layer, they were essentially using their huge fleet of servers to do the heavy lifting, taking the pressure off that single precious database. And finally, playbook number 3 was all about building a safety net. They set up a hot standby, which is basically a clone of the main database, ready to take over instantly if the primary one fails. They added cache locking to prevent a digital stampede when the cache goes down. And they started planning for cascading replication to spread the load out even more. It's all about preparing for when things inevitably go wrong. So after all that, what's the big lesson here? What's the real takeaway for any of us out there trying to build something, trying to get a project off the ground? I think the lesson is actually pretty simple. You don't need to build a perfect, infinitely scalable fortress from the very beginning. In fact, you probably shouldn't. You just need to build a solid foundation that's good enough for right now, one that you can build on top of later. And this quote from OpenAI's engineering blog just says it all, doesn't it? Most of these technologies are good enough for your current scale itself. It's not about chasing the newest, fanciest tech. It's about picking something that works and lets you focus on what really matters. So when you look back, the real hero of this story isn't a specific database technology. It's the pragmatic, get-it-done attitude of the OpenAI team. They focused on their product first, not on building a theoretically perfect system. And that choice is probably why they succeeded. So I'll just leave you with this one question to think about. Is your tech stack scalable enough for what you're actually building today? Are you solving today's problems, or are you trying to solve the problems for 1 million users you don't have yet? The answer to that could make all the difference.